I remember last year I did this 2016 specialist math exam too, but only the extended response question, which is section B. This time, I think I should take the whole thing in English. So this video would be more beneficial to more students who are undertaking this 2020 COVID-19 final exam. By the way, for the statistics and probability question, I will mark it with a clear indication, not examinable in 2020. So let's get started. Question 1 is typically a conceptual question. What is that concept being assessed here? It's this formula, cosecant t equals cotangent squared t plus 1, okay? You can find that on your formula sheet. And then you just need to do some rearrangement. You have x on 3 equals cosecant squared t. And you don't need to square it again because it's already a square. And then y plus 1 over 4 equals cotangent t. Making some substitution, you get x over 3 equals y plus 1, the whole thing over 4, and a big bracket squared plus 1. So you need to simplify this expression, the whole equation a little bit, which is x on 3 equals y plus 1 squared on 16 plus 1. X over 3 minus 1 will be y plus 1 squared over 16. So you should get x minus 3 on 3 by taking the common denominator, and the right-hand side is y plus 1 squared over 16. And therefore, y plus 1 squared as your subject on the left-hand side will be 16 bracket x minus 3 on 3 by multiplying both sides by 16, okay? Choose E. The second question is typically a CAS question. So if you prefer doing it by hand, if it's a linear function, that's fine. But if it's a complicated function, I'd suggest using your CAS calculator. So let's have a look at my CAS calculator. In this case, TI Inspire. I will just create a document and add in a calculator page, DOMAIN, domain. And then you just hit trig, cosine, inverse. You need a fraction template, x minus a, oh sorry, should be a, and over b, comma x, indicating your independent variable. Remember, you have a parameter, b is a positive real number, so you just hit control equal, given that b is greater than 0. There we go. This is your final domain under the particular condition b greater than 0, okay? Alternatively, you could try to solve the inequality, but it might end up with ugly expressions like that. So you need to be very careful in looking at the orders for both endpoints. Under which condition? For example, if b is negative, then you must be very careful with the order here, okay? In this case, we just choose this one as our final implied domain. So let's switch back to the iPad and write down something important. Right. Therefore, B is your final answer, okay? Question 3 is also typically a CAS question. So you can use y equals expand. And then just throw everything f of x into the bracket, comma x. And you should be able to get something like y equals x minus a on x, okay? For this particular rational function, you have two asymptotes. One asymptote is x equals 0, which is your vertical asymptote. The other one is y equals x, which is an oblique asymptote. So let's have a look. X equals 0 and Y equals X only. So we choose C. Right. If you are unsure about the shape of the function, you can just pick and choose the particular value of A. A here is a non-zero real constant. You can choose 1 or -1, whatever number that satisfies the given condition, okay? Question 4. One of the roots of that equation, which is a cubic expression, is 3 minus 2i. B and C are real numbers. So we have complex conjugate theorem. What is complex conjugate theorem? You can say with all real coefficients, real, you have z equals 3 minus 2i. And it must be paired up with v equals 3 plus 2i. But a common mistake will be multiplying these two roots together. No. In order to get the original expression back or recover the original expression, you are thinking of the other way around. From this expression to a solution, you need to factorize. Then from factorized form to general form, you are thinking of, okay, z times z minus 3 minus 2i bracket times z minus 3 plus 2i bracket. So your target is to expand this expression here. Now, with our CAS calculator, you are able to do so easily. Let's have a look. Expand bracket z times bracket z minus 3 plus 2i times z minus 3 minus 2i. Be careful with the negatives here, okay? And then you just get z cubed minus 6z squared plus 13z. So which one is our answer? I suppose the answer should be, let's have a look. I think the answer should be E, okay? Because it comes from z cubed minus 6z squared plus 13z. Right, question 5 is a conceptual question. If argument -1 plus ai equals minus 2 pi on 3, okay, then the real number a is what? Draw a diagram. Thinking of this special angle minus 2 pi on 3, I would say it's roughly here. So this is 120 degrees, this is 60 degrees, but it's in the third quadrant. Now, you are locating the position of -1 plus ai. If it's 60 degrees, you are thinking of a special triangle -1 minus √3, and the radius is always positive. So looks like the answer should be A, because this complex number here is -1 minus √3 times I, okay? And this number here has an argument of 2c's minus 2 pi on 3, okay? A common sense. Question 6. I would adopt a diagrammatical approach. That is, draw a diagram. Let's have a look. Z1 is 2c's pi over 3. All right, hang on a second. Probably I need 2 extra circles. One circle is here with radius 1. The second circle is roughly here with a radius 2. So let's have a look. Where is my 2c's pi on 3? 2c's pi on 3 should be roughly, let's say, here. Okay? 2c's pi on 3. How about the other one? C's 3 pi on 4. Okay, it's here. In the middle, right? In the middle of the second quadrant. So this is Z1, this is Z2, which is C 3 pi on 4. How about Z3? Okay, Z3 is 2C minus 2 pi on 3. So it should be in the same direction of that complex number, but in the opposite direction. Okay, so this one should be Z3 equals 2C minus 2 pi on 3. And then the last one, C minus pi on 4. Like that. Z4 equals C minus pi on 4. Right. The first option, the acute angle between the diagonals of the parallelogram. What is our parallelogram here? It's this guy here. Obviously, I'd say, okay, this angle here is 60 degrees. This is 45 degrees. So in the middle, I think the first option is true. 5 pi on 12, which is 75 degrees. Good. The diagonals of the parallelogram have length 2 and 4. Okay, so this complex number here has a length 2. 2 and 2, 4. 1 and 1, because there's a hidden 1 in front of the C's. So yes, this is correct. How about option C? No, it's not correct. If you are multiplying them together, you should get 2C's pi on 3 times C's 3 pi on 4 times C's 2C's minus 2 pi on 3 times C's minus pi on 4. No matter how you operate with them, if you multiply them together, you're just adding up all the angles and multiplying the radii. As long as the radii is non-zero, you can't get a product of 0. So option C is false. I think we don't need to verify D and E because the question already asked us to find the incorrect option. So let's move on. You could do question 7 either by cast or by hand. This time I performed the by hand calculation. Your dy dt will be half times 2 cosine 2t, which is cosine 2t. But remember, it's a double angle. You could do things like, okay, I would say, let's use cosine squared t minus sine squared t, which is one alternative form in the formula sheet. And then the x dt will be cosine of t, the derivative of sine, minus sine of t. Okay, this time we get cosine of t plus sine of t. Now your dy dx is dy dt over dx dt. So you should get, let's be lazy this time, c minus s, c plus s. C represents cosine t, s represents sine t. The bottom is c plus s. Cancel them out, you get cosine of t minus sine of t, okay? So option A is the correct answer. But here is my warning. If you are doing a short answer question in exam 1 or any part in the exam 2, like the extended response question, don't use these abbreviation unless you are doing a multiple choice question, okay? If you are doing short answer or extended response questions, don't do that. Make sure you write out the full notation like cosine t, sine t, okay? Question 8. Using a suitable substitution where a and b are real constant. Okay, so let's have a look. We definitely have two options. Either u equals x to the power of 4, or you can say u equals 2x to the power of 4. It depends which one we choose. Let's stick with the simple one. Du dx equals 4x to the power of 3. So x to the power of 3 is 1/4 du dx. Now, once you performed the change of variable, you also need to change the terminals. X equals a gives you u equals a to the power of 4. When x equals b, your u value will be b to the power of 4, coming from here. So the integral will be a to the power of 4 to the b to the power of 4. And let's have e to the power of 2u multiplied with 1/4 du dx multiplied with dx. Warning, don't do cancellation here, okay? Don't write any slashes like that. 1/4 in the front, a to the power of 4, b to the power of 4. e to u times du. Let's see if we have such an option. Yes, we have such an option D. What if we use the u equals 2x to the power of 4? Then you should have du dx equals 8x to the power of 3. This time du dx is 1/8. Is 1/8. Hang on a second. The other way around. I'm sorry. X to the power of 3 is 1/8 du dx. So x equals a gives you u equals 2a4. X equals b gives you u equals 2b to the power of 4. And then the integral will be 2a4 to 2b4. And eu times 1/8 du dx times dx. But we don't have such an option because this is incorrect and these two are not correct as well. So we can now moving on to the next part. The next part is a CAS question combined with some conceptual aspect. Now let's have a look. We have a dy dx here with one initial point. We want to find y3. So let's think of the algorithm behind. We are getting from y0 to y1. And y0 corresponds to x0. y1 corresponds to x1. Then the next step or the next iteration is y2 corresponding to x2. Finally, we will get y3 corresponding to x3. But remember, the algorithm of Euler's method is like substituting the previous point into the derivative to get the next point, and so on. So if you are looking at these options, they don't provide you an explicit definitive answer. It's just a form of recurrence relation or iterative relation. To get the next one, which is y3, we need to figure out what y2 is, okay? So the key to this question is figure out what y2 is. Now, with my TI Inspire, I'm able to do things like Euler. Let's have a look. 2x squared minus x, comma, x, comma, y, comma, curly bracket. We start from 2. This is my initial x value. And my final x value, in this case, I need to figure out y2 first, okay? y2 corresponds to x2. So let's fill in the pattern. 2, 2.1, 2.2. This is my target x value. And my initial y value is 0. Step size is 0.1, okay? On Casio ClassPad, if you downloaded eMath from a gentleman's website, his name is Charlie Watson, you should be able to use eMath. 2x squared minus x, comma, what is my x0? 2, y0, 0. And the step length is 0.1. Finally, I need 2 steps in this case. Okay? So let's have a look with my CAS calculator. There we go. Looks like 1.272 is my value for y2. But to get the next one, we need to start from 1.272 plus the step length multiplied with the derivative. What is my value for the derivative? F of 2.2, okay? I need to substitute the previous x value or y value into my derivative function to get the next y value, okay? So the answer should be C, okay? Probably I need to demonstrate the use of EMath. All right, here is my Casio ClassPad. What I will do is using ABC, EMETH, bracket. What is my dy dx? 2x squared minus x, comma. X starts from 2. Y starts from 0. How many, what is the step length? 0.1. And finally, my steps, number of steps, 2 steps. I obtained only exact values, so I will click the first line, then click 0.5 to half. Right. Let's have a look. In the middle, 1.272. So that is a good hint for us to walk along the line, okay? If you change this number here to 3, what you will get here is like, have a look at the middle value, 1.272. So the next bigger value is not what we intended to find. It's actually the previous y value adding on the increment, okay? Right, enough of this question. I should move on to the next one. Choosing C. Question 10. Right. This is a typical type of differential equation question, slope field in particular. So you need to look at the given initial condition and draw an accurate sketch to estimate any possible value you are interested in. So 0 minus 1 is where? It's here, right? Make sure you take a closer look as much as possible and draw things carefully to get the most accurate sketch. Make sure your sketch is not crossing any gradient lines, but just sliding in between 2 gradient segments or just tangential to the segment, it will be fine. Right. This is the left part. Now let's look at the right-hand side. Right-hand side is like, okay, moving on, careful, not crossing any gradients, but could run parallel or tangential to the gradient. Okay, so far so good. Now, with this accurate sketch, let's have a look at the options. Firstly, 3 minus 1. Where is 3 minus 1? 3 minus 1 is here. This is option A. It does not lie along the blue line. No good. How about 3.5 minus 2.5? 3.5 is here. 1 grid, 2 grid, 3 grid, 4 grids, 5 grids. Okay. It's very close to the blue curve we just draw. Now, I would guess option B is a very close option. Very close option. That's it. Alternatively, there is another shortcut if you know how to use DSolve, okay? The syntax for DSolve on TIN file is DESOLVE y dash representing dy dx plus x plus y equals 0, comma x, comma y. But remember, you have an initial condition, so you could just say, let me adjust my writing. Here you have an equals 0, you must have an equation. But then you don't type comma, you type space and space, the space button on your CAS calculator, okay? And you could have y of 0 equals -1. This is the particular format to be accessed, to be identified by your CAS calculator. On CP400, the Casio CAS, you have D capital solve y dash plus x plus y equals 0, comma x, comma y, comma x equals 0, y equals -1, okay? So once you obtain a particular solution from DSolve, you could substitute certain values into the function and see which y value is the closest in the option. So let's have a look. There we go. DSolve y dash plus x plus y equals 0, space and space, y of 0 equals -1, comma x, comma y. All right, a nice looking particular solution. Then substitute x equals 3 or 3.5. Hit Control Enter. Right, -2099, no good. It's not -1. -2.56. Okay, close enough to the option B. That's it. So probably demonstrating how to operate with Casio class type again. Keyboard, Math 3, DSolve, y dash plus x plus y equals 0. You must have equals 0, comma x, comma y, comma x equals 0, comma y equals -1. Close bracket, hit execute. There we go. Now, just highlight everything here. Then put a width given that sign. X equals 3.5. Hit 0.5 to half. Okay, very good. -2.56, blah, 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 blah. Sufficient to prove that our option B is the closest answer. Right, moving on to the next question. Question 11, a typical CAS question. You could perform some by hand calculation, but would be painful. So what is your scalar resolute? What is the formula for that? Because our CAS calculators are not very happy with alpha or A, or it's very hard to find the Greek letter alpha. Let's just call this one U, this one V. A in the direction of B, so U in the direction of V, okay? In that logic. On my CAS calculator, I would firstly define U and then V, and then think of the formula for scalar resolute. Scalar resolute is given by U dot V divided by the length of V, the length of the directional vector. Or you could just say U times vector hat, which is the unit vector along direction of V, okay? Now let's start formulation on our CAS calculator. So where is my CAS? Preferably TIN Spire. Right, Control I, add calculator, and then define U equals Control left bracket 3, 2, A. We're using A to represent alpha. Then hit up, enter. Change this U to V. And the three numbers should be 4, -1, and alpha squared. Good. Now, the scalar resolute is 74 over root 273. So, dot P u comma unit v bracket v equals 74 over root 273. What is our target here? We are actually obtaining an equation in terms of a, and we want to solve for the value of a. Heat control, enter. You should be able to get a equals 4. So alpha equals 4. That's it. Choose B, okay? I don't bother swapping the pages too often. So I will keep going. Question 12 on my CAS calculator page. Question 12 is actually saying two vectors, A and B. A minus B is perpendicular to the vector B. So let's define A1 equals -2, -1, 3. Then define B1 equals -m, comma 1, comma 2. So if A1 minus B1 is perpendicular to B1, then the dot product between them must be 0. And then you can solve for what? Solve for the value of m, okay? So we could either have 0 or 2. Looks like the option C is correct, okay? So let's switch back to our iPad and keep writing some important steps down. Right, the whole idea is A minus B in a bracket is perpendicular to vector B. So A minus B must have a bracket, dot B equals 0, okay? On CAS calculator, it's dot P A1 minus B1 as long as you define them clearly, A1 B1, comma B1 equals 0. Right, question 13. A particle of mass 5 kilograms is subject to forces 12I and 9J newtons. So F1 equals 12I plus 0J. F2 equals 0I plus 9J. The sum of the two forces will be the net force, which is mass times acceleration. So no other forces act on a particle. Don't use your imagination to add in something like 5G, which is 49. No, you only have those two forces. Add them up. That's it. You don't need to do the diagram, okay? So the total is 12I plus 9J. And in front of A, the M value should be 5. 5A equals 12I plus 9J, okay? And A should be 12 on 5I plus 9 on 5J. Is that what we need to find? Probably no, because we are looking for the magnitude. The magnitude means the scalar quantity. So we can't choose option B, option E. We have to choose from either A, C, D, okay? A, C, D are only scalar quantities out of 5 options. Now, the absolute value of A, which is the magnitude of the acceleration, is square root of 2.4, which is 12 on 5, and then squared, plus 9 on 4, 1.8 squared. Looks like the answer is 3, okay? Because 2.4 equals 3 times 0.8. 1.8, hang on a second. Nope, no good. It must be 4 times 0.6. This one is 3 times 0.6. So you are thinking of the third side. The third side should be 5 times 0.6. How do I know that? Because this one is 2.4i. This one is 1.8j. So you are thinking of the length for the hypotenuse, okay? Therefore, choose A. Believe it or not. Better verify that with my CAS calculator. Yes, definitely. How? We have something like 1/5 bracket 12, 9. Okay, there we go. This is my vector, force vector, net force. Now, NORM, which is the magnitude of that force, 3. That's it. We are correct. Very happy. Moving on to the next question. Question 14. What I must say here is this diagram has no problem at all. No, it has one misleading aspect. T1, T2, the length, no, they are not drawn to the scale. For example, if you are using these two vectors to do the vector summation, this is the main diagonal, which should be deemed as the sum of two vectors. But actually, the gravitational force is down to the Earth, perpendicular down to the Earth. So, in fact, how long should T1 be? Let me use the blue color. Should be that long. How long should T2 look like? Like that. Okay? Then you can expand them a little bit to form a rectangle, and this main diagonal here will then be collinear with this mass here. By Newton's third law, they could compensate each other. Same in the magnitude, but different in the direction. Opposite direction, same magnitude. Yes, they can cancel each other out. Okay? So what will be the actual proportion, the ratio? If I say this one is 5G, I would definitely say this one is 3G, this one is 4G, okay? Let me do some relocation for you. I relocate the 4G here with the arrow. I relocate the 3G here with another arrow. See? They form a false triangle. Therefore, T1 over T2 should actually be 3G over 4G, which is 3 over 4, okay? I must choose option B. Alternatively, you could do some unforced resolution, but it involves complicated parameters. You have to set, for example, this angle here is theta, this angle here is half pi minus theta, and do simultaneous equations, which will be ugly, okay? Always remember, in an equilibrium situation with two rows, think the other way around. It's the inverse proportionality, okay? Longer line, longer rope means shorter force for equilibrium situations. Question 15 is also a conceptual question. So if you want to find the net force, you have to find the acceleration first. A common mistake is just finding the v dx. No, you have to multiply it with v. v dv dx is the proper expression for acceleration, or v in terms of x here, not v in terms of t, okay? So 3 minus x squared multiplied with minus 2x, which is the derivative of that expression here. Now, F equals ma, which is 3 times a here. So your actual force will be 3 multiplied with v multiplied with dv dx. So let's have a look. 3 minus 6x plus x to the power of 3 with a 2 in the front. So it will be 6x to the power of 3 minus 18x. Which one looks like the right answer? Choose D. Question 16. Okay. Given that the field is level, a cricket ball is hit from the ground at an angle of 30 degrees to the horizontal with a velocity 20 meters per second, typically projectile motion question. So your initial speed is 20 meters per second. To write it in component form for vector, velocity vector, you need to think of resolving them, okay? So this component will be, okay, 30 degrees here. So it's 20 times cosine 30 degrees. This one will be 20 times sine 30 degrees, okay? By some simple geometry, trigonometry. And so V0 will be 10 times root 3i plus 10j, okay? Your acceleration is only subject to gravity, no air resistance, negligible air resistance. So A is 0i minus g times j. Velocity vector, where you anti-differentiate that, you should get c1i plus c2 minus g times t bracket j. Subbing in t equals 0, b equals those things. You get b equals 10 root 3i plus 10 minus gt bracket j. Now, if you are thinking of the whole process, it's hitting, flying up, reaching the highest point, then going down until it hits the ground. So the ground is level. If I found the time to reach the highest point, that means I have traveled half of the range. Range means for level situation, from the starting point to the point where it hits the ground. So this one is half t, this one is half t, okay? How do I get half t? Half t is when by equals 0, 10 minus gt equals 0. We have t equals 10 over g. So the whole t will be twice that amount, 20 over g. Now, I want to find the horizontal distance traveled by the ball. I just multiply this time with the horizontal speed here. So it will be 10 root 3 multiplied with 20 over g, which is 200 root 3 over g meters. Therefore, we choose D, okay? If some of you are doing physics, you guys are in heaps amount of advantage than those who are not doing physics. You may want to use physics formula, but in some cases where air resistance are not negligible, you have to use calculus, okay? For example, 2016 sample exam or 2019 exam 2 and Northern Hemisphere timetable, etc. You have to be able to do the differentiation or anti-differentiation with vector functions. Right, question 17. A body of mass 3 kilograms is moving to the left in a straight line at 2 meters per second. It experiences a force for a period of time, after which it is then moving to the right at 2 meters per second. The change of momentum, okay, in the direction of the final motion. So the final motion is to the right. Let's label this one as positive, okay? At the beginning, it's to the left. V equals minus 2 meters per second because it's opposing the final direction. After some period of time, the velocity, let's say this one is u, initial velocity. The final velocity is plus 2 meters per second. So the change in velocity will be v minus u, which is plus 2 minus minus 2. And it will give you 4 meters per second, okay? So the change in momentum will be mass times delta v, which is 3 times 4, and it will give you 12 kilograms meters per second. So the answer is E, okay? Question 18, 19, 20, they are all statistic questions. For future purposes, for any candidates who are watching this video after 2020, they might be useful, okay? For 2020 candidates, if you want to skip them, that's fine. Oranges grown on a citrus farm have a mean mass of 204 grams with a standard deviation of 9 grams. Okay, oranges, let's say OI is a normal distribution with 204 as its mean and 9 to the power of 2 as its variance. My lemon I, individual lemon mass, will be normal distribution 76, 3 to the power of 2 as its variance. The masses of the lemons are independent of the masses of the oranges. Okay, the mean mass and the standard deviation in grams respectively of a set of 3 oranges and 2 lemons. Okay, so let's say a sum S equals the first orange plus the second orange. You can't treat for individual items like candies or how many cans of Coke, how many cans of drinks. You have to use individual addition rather than multiplying it with a number, okay? Plus L1 plus L2 plus L3, okay? Like this for individual items. If you are given a linear relation, that's another story. So this time we have e to the expected value of S will be expected value of O1 plus O2 plus L1 plus L2 plus L3. So you can just sum the individual mean values up. It's 204 plus 204 plus 76 plus 76 plus 76. Okay? With my calculator, this should be giving me some answer, but what will be the variance of S? Variance of S is variance O1 plus O2 plus L1 plus L2 plus L3. So you are actually saying variance of O1 plus variance of O2 plus variance of L1 plus variance of L2 plus variance of L3. Okay? A common mistake will be working with variance 2O1 plus 3L1, which is 2 squared variance O1 plus 3 squared variance L. No, it's no good. In this case, you are not being given a linear function like S equals 2O plus 3L. That's another story. For individual items, you are dragging out their weighting like 1 squared, 1 squared, 1 squared, 1 squared, 1 squared, okay? So it's actually 2 times 9 to the power of 2 plus 3 times 3 to the power of 2, okay? 2 lots of the variance O1, 3 lots of variance L1, that's it. Now, working with our CAS calculator, it should give us, let's have a look. 204 times 2 plus 3 times 76. Right. So it's 636. How about the standard deviation? You need to take the square root of something. 2 times 9 to the power of 2 plus 3 times 3 to the power of 2. Ooh, something goes wrong here. Let's have a look. 76. 3 oranges. Okay, I see where I went wrong. So it should be the other way around. It should be 3 here, 2 here. Okay, 764. That should be correct. And this one should be 3. This one should be 2. Okay, 3 root 29. So option A will be our correct option. Okay, let me fix some of my mistakes. It's actually O1 plus O2 plus O3, L1 plus L2. So O3, L1 plus L2, 204. 764. The same idea applies to the next line. O3, L1 and L2. So this one is variance O3. So this number here is 3, this number here is 2. You should be getting, take a square root of that, square root of that, square root of that, square root of that to get 3 root 29. That's my standard deviation S. Choose A. Right. Question 19. We have a sample of 100 bananas, n equals 100. And the mean mass is 210 grams. Standard deviation, that's the population standard deviation. So mu equals 210, sigma equals 16. And the sample mean standard deviation, because we are looking for, okay, 95% confidence interval, should be mu minus z score sigma divided by n, smaller than mu plus z score times sigma divided by n. That is my confidence interval formulation here. And we are able to use my CAS calculator, say, right, a 95% confidence interval. Let's use menu, statistics, confidence intervals. Choose Z interval. Data input method is stat. Choose OK. And sigma is 16. The mean value is 210. How many bananas? The sample size, 100. Sea level, because it's a 95% confidence interval, we just leave the 0.95 alone. Choose OK and hit Control Enter again. It's 206.86, 213.13. All right, so which one should be our correct option? I suppose that's option B, okay? Option B. Let me demonstrate how we can use Casio ClassPad. Right, go to menu, statistics, calculation, interval. Choose one sample Z interval by default selection and choose variable. Choose next. Sea level is 0.95, sigma is 16. Mean value is 210. Number of bananas, 100. Hit next. All right, there we go. Very similar procedure to the procedures we use in TIN Spire, okay? Right, it's time for us to move on to the last multiple choice question. So let's have a look. Question 20, another CAS question. But before we use CAS, we need to derive some probability statement. The lifetime of certain brand of batteries is a normally distributed random variable with a mean lifetime of 20 hours and a standard deviation of 2 hours. Okay, so the original distribution is a normal 22 squared. That's my variance, okay? A random sample of 25 batteries is selected, so n equals 25. The mean lifetime, which means the average lifetime, is like x1 plus x2 plus blah, blah, blah. You add the 25 distributions up and divide it by 25, okay? So this is your sample mean distribution. And X bar should be following the normal distribution with the same mean value 20, but now the variance should be 2 squared over 25, okay? You are dividing the variance by the number of sample size. So your mu X bar here is 20. Your sigma X bar here, I mean the sample mean standard deviation, not the population standard deviation, is 2 over 5 once you take the square root of that expression. And I want the mean lifetime, which is X bar, to be greater than, exceeds 19.3. So it's norm CDF from 19.3 infinity to then with mean value 20 and standard deviation 0.4 if you wish to use 0.4, okay? Let me demonstrate how we can operate with CAS calculator. Menu, probability, distributions, norm CDF. From 19.3 to infinity. Mean value is 20. Standard deviation is 2 over square root of 25, which is 2 over 5 or 0.4, whichever you like. There we go, 0.9599, okay? So the last option is the option we want. Choose E, okay? Right, let me switch back to my iPad. Right, let me take a short break, then I will go through the remaining 6 extended response questions. Okay, now I'm back. So let's look at the first question. We want to find any stationary point of the graph of f. Express my answer in coordinate form giving values corrected 2 decimal places. Okay, only 1 mark question. So I will be writing down f dash of x from my CAS calculator. And the only solution, I guess, is x equals 1.11338619, okay? And f of 1.113386 blah, blah, blah will give you 5.94565, blah, blah, blah. Correct to 2 decimal places, the stationary point is 1.11, 5.95, okay? Just in case anytime you need the exact value, you do need to keep them in exact form. Find the point of inflection of the graph given in part A. Express your answer in coordinate form. Okay, correct to 2 decimal places as well. So with my CAS calculator, I obtained f double dash x equals 8 plus 2x cubed over x to the power of 3 equals 0. This will give us x equals something like minus 1.587, 401, 052, blah, blah, blah. So f of minus 1.58740, blah, blah, blah. Remember, I'm quoting everything here. I kept all digits for the better accuracy. This will give you 1.587, 401052, blah, blah, blah. So the point of inflection is minus 1.59, minus 1.59, okay? For a 2 marks question, you need to demonstrate some methodologies, okay? Now, let's look at the graph sketching question. I realize my time is very tight, so I just demonstrate whatever I obtained from my CAS calculator, but I will make some important notice here. First of all, asymptote. Even though one of the obvious asymptote is x equals 0, which is the y-axis, you still strongly encourage to draw the asymptote, okay? Just a little bit aside of the y-axis, like what I'm doing here. Don't just label x equals 0, draw it. We can label everything correct to 2 decimal places. Good. So I guess from your CAS calculator, you will be able to see one of the x-intercept is -2, 0, -1.59, and a -1.59. Okay, so this is -1.59, -1.59, okay? Now, you need to show some change of concavity like this. And don't forget your graph must end at -3 or 3. So don't go over that particular point. In fact, it's roughly here, okay? Or actually, for better accuracy, it should be here. Let me clean that a bit up. Right, should be fine. If you want the coordinate, it will be -3. And let's have a look. Control up. Four plus x squared plus x to the power of 3 divided by x. Right, it's not exactly the same thing in the same window setting. So this one should be 16. This one should be 4. This one is 1. Make this number 3. Make this number -3. And this is 1. This should be -16. All right. Very similar in the scale to the scale on the exam paper. If you want to add some grid, that's fine. 2, 6, 3. There we go. So it's a bit above y equals 4, okay? If you want the coordinates, you just press Control I and calculator, F1, curly bracket, -3, 3. All right, 14 on 3, 40 on 3. That's it. That's what I really want to see. Where is my iPad? Let's have a look. Okay, we are back. 14 on 3, but in this case, you don't need to label them because the question did not ask you to label them, okay? And you have 1.11, should be roughly here. 1.11, 5.95, okay? Something like that. And the 3F3 is 40 on 3. A bit above 12. 3, 40 on 3. Right. This should be a accurate enough sketch. Don't leave your graph hairy like this. Draw some smooth curve to cover the unsmooth bit. Okay. So make sure you are using 2B pencil to sketch the graph. And like this. You can see I'm taking extra care when I'm drawing a graph question. Okay, this should be fine. Right. A glass is to be modeled by rotating the curve that is part of the graph where x is going from -3 to -0.5 about the y-axis. So where is -3 from here to -1.5? Okay, roughly here. So I want this bit to be rotated around the y-axis like that. So this time I'm using, okay, the length of this curve. The length of this curve. I want a definite integral in terms of x. So the arc length is going from -3 to -0.5. Square root of 1 plus the derivative of f squared dx. It will be -3 to -0.5 square root of 1 plus some squared 2x squared plus x squared minus 4. Actually to the power of 3, not squared at the beginning. And x squared is here. dx, don't lose your dx. It's very important. It's like a right bracket, left bracket, right bracket. And I want to find the length of this curve. Let's have a look at my CAS calculator and see how we go with that. Arc length, f1 of x, comma x, comma -3, comma -0.5. Ooh, very ugly expression, but I believe it's identical to the one we just dropped down. Let's have a look here. Shift plus, hold on a second. Shift plus from -3 to -0.5. Square root of 1 plus something like shift minus x, f1 of x squared dx. Okay, exactly the same thing. So if I use that one and hit Control Enter, 13.718, round it up. Alternatively, I can just use this line here and hit Control Enter. Exactly the same thing. All right, answer obtained. Okay, the volume of the solid form is given by V equals AC to B, x squared dy. So it's like from -3, 14 on 3. At this point on your CAS calculator, you should be able to find that -half minus 33 on 4, xy, xy. And it's rotated around the y-axis. So we are using v equals pi integral from the lower y value -33 on 4 to the upper y value 14 on 3, x squared dy. We are not suggested to evaluate this integral. We just need the values of a, b, and c. So your a value should be pi. B value is the upper terminal, 14 on 3. C value is -33 on 4, okay? And that's it for the very first question. So we are moving on to the next one. Question 2, the first two parts. Find the equation of this line in the form of y equals mx plus c. 2 marks, demonstrate some working. The points of intersections between that and that, 2 marks. Probably also need to demonstrate some working, so let's have a look. For the very first question, substitute z equals x plus yi, I suppose. Z equals x plus yi, you should get x minus 1 plus yi absolute value equals x plus 2 plus y minus 3 in the bracket I. Okay, now it's time for us to do some basic calculator operations. Let's just write this line anyway. X minus 1 squared plus y squared equals square root of x plus 2 squared plus y minus 3 squared. Okay, it's time for us to rewrite this one in y equals mx plus c. So we just leave the space here. Solve for y and then see what we get. I need an absolute value. Probably it's a good habit to go to another problem. X plus yi minus 1 equals absolute value x plus yi plus 2 minus 3i. All right, there we go. Then we solve for y. Answer, comma y. Y equals x plus 2. And then I want to find the point of intersection between the line and the circle. So let's look back and finish the question first. So this equation here has an alternative form, equivalent form, y equals x plus 2. This guy here can be written as x minus 1 squared plus y squared under a square root equals 3. So your equation of circle will be that. We can solve simultaneously, and let's have a look. We should have menu, algebra 7-1. Two equations. The first equation, the second equation. Okay, these 2 points are the solutions, but we better express them either in coordinate form or complex number form, because we've been given 2 complex relations in terms of z. So let's have a look. X equals minus 2, y equals 0, or x equals 1, y equals 3. So either 2, 0, or 1, 3. Or we can say z equals minus 2 plus 0i, or z equals 1 plus 3i. Okay? Now, moving on. Because we know this line here is y equals x plus 2. A straight line should be drawn like this. And z minus 1 equals 3. This is your center going through here, going through here. Going up by 3 units, going down by 3 units. Okay, 4 vertices located. And use a compass, okay? Make sure you buy a compass. That is very crucial suggestion I always make to all of my students each year. Buy a compass, okay? And draw a perfect circle. Sketch them, better label them. Z minus 1, absolute value, z plus 2 minus 3i. And this guy here is z minus 1 absolute value equals 3. The line cuts the circle into two segments. Find the area of the major segment. So, how about do some copy paste. Copy and paste here. We want the area of the major segment. So it's this guy here. The angle, instead of using half pi, this is half pi. We use the outer angle, 3 pi over 2. For any segment, you are able to use this formula. Area of segment is given by half r squared theta minus sine theta. In this case, the radius is 3. The theta is 3 pi on 2 minus sine 3 pi on 2. And then you just type everything here into your CAS calculator and obtain the answer. So it will be half times 9 times 3 pi on 2 minus sine 3 pi on 2. Let's see, okay. 9 over 4, 3 pi on 2. Okay, or in expanded form, you could say it's 27 pi on 4 plus 9 on 2. Right. Even though this part is very small, you still can't miss it. 1 mark. Don't skip that part. It's very important. Argument z equals minus 3 pi on 4 in part C. So, looks like a straight line like that, but it's a ray. So the starting point must be excluded, okay? Let's label this one 0 plus 0i. Excluded, okay? A clear open circle must be drawn. And this is argument z equals minus 3 pi over 4. Write down the range of values of alpha for which a ray with the equation intersects the line. All right. Let's have a look. This is your line, right? So your ray is here. When the angle here, alpha pi equals minus 3 pi on 4, they are running parallel, and hence they don't have any point of intersections. But if the line is a little bit, say the angle is a bit bigger, closer to the x-axis, you could have an intersection here, or like that, or like that. But remember, it's the principal argument. Any principal argument must automatically satisfy this relation here. Greater than minus pi, smaller than or equal to pi, okay? So your alpha pi must be smaller than minus 3 pi on 4, but greater than minus pi. So alpha is greater than minus 1, smaller than minus 3 over 4. However, have a look the other side. Think of the other direction, the opposite direction. So this is pi on 4. If it's greater than pi on 4, the rays will look like that until it reaches pi, okay? So we have alpha pi greater than pi on 4, but it can be smaller than or equal to pi. Therefore, your alpha value is smaller than or equal to 1, but greater than 1/4. So alpha will be in the interval of minus 1 excluded, minus 3 over 4, union 1 over 4, comma, 1, close bracket, okay? These 3 values have open bracket, but this last value here must have close bracket because of the argument restriction. All right, question 2 finished. Let's have a look at question 3. A tank initially has 20 kilograms of salt dissolved in 100 liters of water. Pure water flows into the tank at a rate of 10 liters per minute. Okay, so they give you the differential equation already. You don't need to derive the differential equation for the first case, but if you really want to derive the differential equation, it's not very hard at all. Flow in dVdt in equals 10. The concentration in pure water, nothing. Out, dV dt out equals 5. C out, what is my C out? It's the amount of chemical divided by the total volume. Since you've been given this differential equation directly, you can solve it. How? dx dt equals minus x over 20 plus t, okay? And separation of variables will allow you to perform integrations like that. Don't forget your integration sign here. Okay, now I will introduce an advanced technique using definite integral to solve the differential equation. So change the letter x to u and make it du here. So your initial amount of salt is t equals 0, x equals 20. I will put the 20 here and an x here. From a known x value to an unknown letter x. But make sure you have a u here, okay? Different letter, okay? You can't use same letter at all places on your left-hand side and right-hand side. Your right-hand side, okay, so it's 20 plus, let's say v minus 1 dv. And this should give you 0 and a t, okay? Using this one can help you avoid the long, painful process to find the integration constancy and the following simplifying steps. So let's have a look at the CAS calculator and see how we can perform relevant calculations. Control I, add a calculator, Shift plus equals Shift plus 20 to x, 1 over u, t, 0, fraction, minus 1 over 20 plus b dv. There we go. This is my derived relation, okay? Now you can solve for what? Solve for x. So you could have, either this one or that one. So which one should we choose? Because the initial value is, let's say, 20 plus 20. I can only choose the second option, and I could add some conditions upon that. X greater than 0 and t greater than or equal to 0. See? It will reduce the absolute value to a non-absolute value expression. There we go. So how should I write down my working steps? Have a look here. Right. So you should have log E of absolute x over 20 equals minus log E absolute t plus 20, absolute value over 20. you can say since t is greater than or equal to 0, x is also greater than 0, no need for absolute values. Therefore, log e of x over 20 is minus, let me write everything clearly, legibly. And it should give you x equals 400 over t plus 20. That's it. A second tank initially has 15 kilograms of salt dissolved in 100 liters of water. A solution of 1/60 kilograms of salt per liter flows into the tank at a rate of 20 liters per minute. The solution of salt and water, which is kept uniform by stirring, flows out of the tank at a rate of 10 liters per minute. So my initial condition is y0 equals 15 because we are using a new letter to represent a second tank's mass, the amount of salt in the second tank. I want the expression for the concentration. So concentration second tank is the amount y divided by the volume in the second tank, which is y over initial amount of volume plus flow in minus flow out multiplied with time. So C second will be y over 100 plus 10t. Or if you wish, you could simplify that a bit. 10 times 10 plus t, okay? And remember in the second tank, concentration in is this guy here. Concentration out is the concentration of any amount of salt in the tank. It's being stirred and kept uniform by stirring. Okay? So this guy here is my concentration out. Now, we want to show that the differential equation relating y and t is this guy here. So definitely, I'm going to use some formulation here. The dy dt is the rate of y with respect to t. It will be given by dy in dt minus dy dt out. The first bit is c in times dv dt in minus c out dv dt out. So C in, concentration in, is 1/16 multiplied with 20 liters per minute minus concentration out is y over 10 times bracket 10 plus t multiplied with 10. So this will be 1/3 minus cancel y equals 10 plus t, okay? Therefore, rearrange it, you should get dy dt plus y over 10 plus t equals 1/3, okay? Make sure you demonstrate all necessary formulation and substitutions, okay? That's it. Then I want to verify by differentiation and substitution into the left side that this function here satisfies the differential equation in part C, verify that a given solution for y also satisfies the initial condition. So let's start with the easy one. Initial condition. My initial condition is y0 equals what? Let's have a look at the previous page. 15 kilograms of salt. So I want to verify that. Sub in t equals 0. Y of 0 is 0 plus 20, 0 plus 900 divided by 6, 10 plus 0, which is 900 divided by 60. So it will be definitely 15 kilograms of salt. That's it, correct. How about the differential equation? Let's write differential equation. What is that? The left-hand side is dy dt plus y over 10 plus t. The right-hand side is 1 over 3. So this bit is left-hand side. This bit is right-hand side. By differentiation and substitution, so I want to show my derivative here. Not necessarily to show every step to derive the derivative, but you can just simply state dy dt equals what, okay? So let's have a look here. Right, so from my CAS calculator, let's have a look. Shift minus t. T squared plus 20t plus 900 divided by 6, 10 plus t. Okay, this is my dy dt, okay? So we are able to proceed further. Now, 16 minus 400 divided by 3t plus 10 squared, okay? Left-hand side equals 1 over 6 minus 400 divided by 3t plus 10 squared plus something divided by 10 plus t. T squared plus 20t plus 900 divided by 6, 10 plus t. Like this. Write the substitution clearly. And then we can keep simplifying everything. 1 over 6 minus 400 divided by 3t plus 10 squared. This time you can merge these two together at the bottom. So it's t squared plus 20t plus 900 divided by 6 over 10 plus t squared. What else should we do? Looks like we have ended up with a dead end, but keep writing the first two terms as it is. Then think of completing square. And if you break 100 out of 900, you have 800 remaining. So it will look like that, isn't it? And 1 over 6 minus 400 divided by 3t plus 10 squared plus t plus 10 squared divided by 6 over t plus 10 squared plus 3, 400 on 3 t plus 10 squared. These two terms will go away, and have a look at these two options. They cancel each other out. So you have 1 over 6 plus 1 over 6, which is 1 over 3. Isn't this one the right-hand side? So we finished our verification by differentiating, and most importantly, appropriate substitution and simplifying, okay? So differential equation verified. That's it. Right. Last part. Find when the concentration of the salt in the second tank reaches 0.095 kilograms per liter. Give your answer in minutes, correct to 2 decimal places. So the concentration is Y. Actually, I should write the concentration as a function of time is the Y as a function of time divided by the volume. So the volume is 100 plus 10t, isn't it? So you should have t squared plus 20t plus 900 divided by t plus 10 squared, if I'm not mistaken. Let me have a look. Now, it's not squared here. It's 6 times t plus 10, then divided by 100 plus 10t. Put a bracket here. It will be 0.095. And you say solving for t. We want to find the value of t where t is greater than or equal to 0. Let's have a look at our CAS calculator and see how we go. So I need a fraction template. This is 100 plus 10t. Copy this bit here. Right, looks like this will be an appropriate equation to be solved. Comma t. Of course, we need to reject the negative value of t and retain the second one, okay? So that's it. Therefore, t equals 3.05 minutes. Easy peasy, lemon squeezy. So let's move on to the next question. Oh, typically a spare page, continuous over page. As I said before, big bosses coming. So remember, warn yourself, guys. Okay. Show that the two ships will not collide. What does it mean by collide? Same place, same time. That will be the main principle we establish our argument upon, okay? So equating xa equals xd. 5, 1 minus t equals 4t minus 2. 5 minus 5t equals 4t minus 8. 9t equals what? 13. T will be 13.09 seconds. If I'm not mistaken. No, t hours, not seconds. Hours, kilometers. YA equals YB gives you 3 plus 3t equals 5t minus 2. Let's have a look. 2t equals what? 5. T equals 5 on 2. Since tx is not equal to ty, we can't have xa equals xb and ya equals yb at the same t. Therefore, the boats cannot collide, okay? Right, next one. Sketch and label the path of each ship on the axis below. Show the direction of motion for each ship with an arrow. So, do some simple substitution. RA of 0 will be 5i plus 3j. 5, 3. Where's 5, 3? Here. This is ship A. Oh, actually, I should rephrase my choice of word here. Ships, not boats, okay? They are not the same thing apparently. 5, 3. And let's say If it's 1, if it's 1, okay, so 0i plus 6j. It's a straight line, isn't it? Good. Now, another path for the second boat, boat B. Let's see. Initial t equals 0 initially. Minus 8ji minus 2j. Minus 8 minus 2. Minus a minus 2. How about r of b at t equals 1? 1 minus 2 minus 1. Minus 4i 1 minus 2 plus 3j, okay? Minus 4, 3. So it should look like that. Just that is boat B. No, not boat. Sheep B. Minus 4, comma 3. Almost there. Now should be fine with that, with an arrow. All right, all finished. I think I marked in everything necessary. And let's move on to the next part. Okay, find the obtuse angle between the path of the two ships. Give your answer in degrees correct to 1 decimal place. For angle between the path of two particles, you always want to use velocity, okay? So let's have a look. Velocity A equals what? Velocity A is like minus 5, 3. Velocity B is 4i plus 5j. VA dot VB divided by absolute value VA, absolute value VB equals cosine theta. Then you can find the value of theta by doing this. So you should be able to get cosine inverse minus 20 plus 15 over root 25 plus 9 root 16 plus 25 multiplied with 100 degrees divided by pi. So what will the answer be? Let's have a look. The answer should be 97.7 degrees, okay? Right, the next part. Find the value of t correct to 3 decimal places when the ships are the closest. So the distance between their current places are the closest. I want to define distance of t is position vector b of t minus position vector of a, then take the magnitude. So it's square root xb minus xa bracket squared, yb minus ya bracket squared. This will give you square root of 85t squared minus 254t plus 194. Then you can just solve in for d dash t equals 0. And this will give you t equals 127 divided by 85 hours. Correct to 2 decimal places, t is approximately 3 decimal places, 1.494 hours, okay? Find the minimum distance between the two ships in kilometers, corrected 2 decimal places. So we just substitute 127 divided by 85 to get the most accurate answer first, the exact value if it's possible. Then round it according to the requirement of the question. So you should be able to get 2.06 kilometers, correct to 2 decimal places as required. Okay. So that is my final part for question 4. Let's move on to question 5. A model rocket of mass 2 kilograms is launched from rest and travels vertically up, okay, from rest. T equals 0, B equals 0. Vertical propulsion force 50 minus 10t newtons after t seconds of flight where t is 0 to 5. Okay, assume that the rocket is subject only to the vertical propulsion force and gravity. Probably I need to draw something like this. Propulsion force is like 50 minus 10t upwards. And this is 2g downwards gravitational acceleration times the mass. And this is the positive direction. I need the equation of motion first. So always start with F net equals ma. This gives you 2a equals driving force. The only driving force is the propulsion force minus the retardation force, 2 times 9.8. So 2 dv dt will give you 50 minus 60, 19.6 minus 10t, okay? So 2 dv dt will be 30.4 minus 10t, and the dv dt equals 76 over 5 minus 5t, okay? That is how you show the required result, okay? Make sure you start from an appropriate equation of motion like the second line. Now you want to find the velocity of the rocket after 5 seconds. So you can clearly tell B is 76 over 5 minus 5t dt, antiderivative, and it will give you 76 over 5t minus 5 over 2t squared plus c. B0 equals 0, 0 minus 0 plus c equals 0. Therefore, B is just 76 over 5t minus 5 on 2t squared. Then you just substitute t equals 5 and you will get something like this. And we must retain the exact value for our answer. So be very careful. You need to evaluate this one. Leave it with 27 over 2 meters per second, or you can say 13.5 meters per second, okay? Either answer will be acceptable. Now you want to find the height of the rocket after 5 seconds. There are several different various attempts, but here I really want to emphasize, okay, I'm not using X, I'm using H. Let H be the height. The H dt, which is your velocity. This gives you H equals integral 76 over 5t minus 5 on 2t squared. Don't forget your dt, okay? So h will be 38 divided by 5t squared minus 5 on 6t to the power of 3 plus d, okay? Now, at the start, the height is 0. So 0 minus 0 plus d is 0. Therefore, h is 38 on 5t squared minus 5 on 6t to the power of 3. And the h of 5 will be 515 over 6 meters, which is approximately 85.83 meters, okay? That's it. Alternatively, if you want to take a shortcut, you can just do things like 0 to 5, 76 on 5t minus 5 on 2t squared, the whole thing dt, which should give you the delta h, okay? Because you are always moving upwards. The acceleration is always in the direction of the velocity for the first 5 seconds. You don't need to worry about any change in the velocity direction. So your displacement is the distance covered. This should also give you 85.83 meters, okay? Now, after 5 seconds, when the vertical propulsion force has stopped, the rocket is subject only to gravity. Find the maximum height reached by the rocket. So you need to break that motion to various stages. So this is h equals 0. This is h equals 515 over 6. Where is this place? This place, you have your velocity 0. This place, you have velocity 27 on 2. Stage 1 has passed. So we need to analyze stage 2. For stage 2, gravitational acceleration a equals minus 9.8 only. So let's use some, and let's have a look. Let's say this one is h max, okay? Displacement. Delta h equals h max minus 515 over 6. Acceleration a equals minus 9.8. And u equals 27 on 2. V equals 0. How about v squared equals u squared plus 2a times delta h, which is s here. 0 will be 27 on 2 squared minus 2 times 9.8 times 5, hang on a second, h max minus 515 over 6. And we can solve for h max here. Leave it with our CAS calculator and see what number we can obtain. Good. 95.13 blah blah blah. That is my final answer. Correct to 2 decimal places. Having reached its maximum height, the rocket falls directly to the ground. Okay, so I want to borrow the whole thing again. Let's break everything into 3 stages, okay? Last one, stage 3. Stage 1, T1 equals 5. Stage 2, I think V equals 13.5 minus 9.8 T, T2, okay? So V equals 0, 13.5 minus 9.8 T2 equals 0. Therefore, T2 equals 13.5 over 9.8. Because for the second stage, it's still moving up but decelerating. And then stage 3. Stage 3, we need to borrow the previous answer, which is this guy here. Now U equals 0, A equals 9.8. Let's treat downwards as positive. And now your displacement, your target displacement is from here to here. So H equals 111875 divided by 1176, half AT squared, UT plus half AT squared gives you 111875 divided by 1176 equals half times 9.8 times T squared. Solving this one, you will get T equals 25 root 2685 divided by 294. This is my T3, okay? So total time will be T1 plus T2 plus T3, and it's 10.8 seconds, if I'm not mistaken, okay? Add them up. That's it, finished, question 5. So we are moving on to the last one. If you want to stop it here, I'm okay with that, but for future references, you can just keep looking at question 6. The mean level, all right. X is a normal distribution, mu equals 1.1 milligrams per liter. Standard deviation squared is 0.16 squared, okay? So X bar will be normal distribution, mu still be 1.1, but this time I need sigma squared over n equals 0.16 squared over 25. So your mean value is 1.1. Your standard deviation X bar is 0.4 over 5, which is 0.032 milligrams per liter. This one has milligrams per liter as well. Okay, sample of 25 cities. The actual mean is 1.2 milligrams per liter. The mean level has increased, so we are actually looking at H0 mu equals 1.1. Okay, we are comparing this one with the original one. Don't jot down 1.2 here, otherwise you will be penalized. Okay, and H1 is mu greater than 1.1. Okay. Remember, we are always comparing the sample mean with the population mean. That's why we need to stick with mu0 here. The p-value is given by what? It's given by X bar greater than 1.2, greater than the sample mean value or smaller than, depending on which or alternate hypothesis we are working with. Now, your mu equals 1.1, sigma X bar is 0.032, okay? So you are actually working out the normal CDF value. Alternatively, you could just do things like, let me show you. Manual probability distributions, CDF, from 1.2 to positive infinity, greater than, right? Mu value is 1.1. Sigma is, you can say 0.16 divided by root 25, which is 5. Okay? Should give you that number, but I don't quite like the, yeah, it's the scientific notation. I really hate that one. So the answer should be like 0.000889, okay? Something like that. Moving the digits to the left, how many times? 4 times, okay? Right. So I need to switch back to my iPad and finish my writing. Which is approximately 0.00009, okay? Correct to 4 decimal places. You could be penalized if you are writing a scientific notation here. So make sure you know how to convert your scientific notation back into normal decimal notation. We are comparing my p-value with the 5% level of significance. So this time p-value is 0.0009, which is way smaller than 0.05. What does that mean? Say, this is my X bar distribution. This is 1.1. My 1.2 is here. My rejection region is here. Reject H0. Do not reject my null hypothesis, okay? So, as the p-value suggested that X bar equals 1.2 is in the rejection region. The sample H0 should be rejected, and the sample supports H1, the main pollution level has increased. Okay? Supports H1. Yes, it has increased. Greater than, okay? For this test, what is the smallest value of the sample mean that would provide evidence that the mean level of pollutant has increased? So we are working out the XC bar here, okay? If you don't mind, you can use your, say, inverse norm distribution, okay? Using inverse norm CDF. Mu equals 1.1, sigma equals 0.032, using the sample mean standard deviation, okay, instead of the population standard deviation. And remember, this one is 0.05, okay? This bit is 0.05, your level of significance. So the left-hand side must be 0.95. Left tail area equals 0.95. This will give you xc bar equals 1.153, okay? Let me show you how you can obtain this answer. Menu, probability distributions. Inverse normal, area is 0.95. The left tail, okay? And 1.1, 0.032. That's it. The next line, let me directly figure it out. It's norm CDF. I mean the next part. X bar is greater than that value. Infinity, 1.1, comma. The standard deviation remains unchanged, 0.032. All right. But let's have a look at the question first. How about x bar smaller than that number here under a different sample mean? So this time x bar 2 is normal distribution. Let's say 1.2, 0.032 squared. So the probability of x2 bar smaller than 1.163, given mu equals 1.2, should be given by the following calculation. I will show you. We can borrow that normal CDF, but smaller than, right? Negative infinity, comma. This number here, change 1.1 to 1.2 and see how we go. All right. Hang on a second. No. 1.163. There we go. This time the value is much more reasonable, okay? Using the given information. So that's it. Correct just 3 decimal places. Done. Hopefully you guys find this video helpful, at least in some way. And good luck with your 2020 Specialist Math both exams. Thanks for watching. See you next time. Bye-bye.